What if I told you that everything you know about electric vehicles might be completely wrong? Imagine this for a second. You're standing in front of a car that looks ordinary enough. Four wheels, sleek design, nothing particularly special at first glance. But then you learn something that makes your brain short-circuit. This vehicle doesn't need charging stations. It doesn't drain its battery. In fact, according to its creator, it generates its own power indefinitely. Sounds like science fiction, right? Like something out of a fantasy novel where the laws of physics take a vacation. Well, buckle up, because what I'm about to share with you is going to challenge everything you thought you understood about energy, transportation, and what's actually possible in our world. We're talking about an invention that could potentially flip the entire automotive industry on its head. An electric vehicle that supposedly runs forever without ever needing external power. Now, I know what you're thinking. That's impossible. That violates the laws of thermodynamics. That's perpetual motion nonsense. And honestly, those were my exact thoughts too when I first heard about this. But here's the thing. We didn't just hear about it. We actually got our hands on this vehicle. We tested it. We pushed it to its absolute limits. And what we discovered left us questioning our understanding of what's achievable. So let me take you on this journey with us, because over the course of one intense week, we uncovered 7 mind-bending discoveries that might just reshape how you think about the future of transportation. And fair warning, some of what you're about to hear is going to sound absolutely crazy. But sometimes the craziest ideas are the ones that change the world. Before we dive into what we found, let me set the stage for you. When we first approached this test, we came in with healthy skepticism. Actually, let me be honest, we came in thinking this was probably going to be a spectacular failure. A well-meaning but ultimately flawed attempt at something that fundamental physics says shouldn't work. But we also came in with open minds, because history has taught us a valuable lesson. The people who get laughed at today sometimes become the visionaries we celebrate tomorrow. So we designed a comprehensive testing protocol. No shortcuts, no softballing it. We mapped out a full week of intensive trials that would expose any weaknesses or false claims. City driving with constant stop-and-go traffic, highway cruising at sustained high speeds, mountain roads with steep inclines that drain conventional EV batteries faster than almost anything else, even some rough terrain and off-road conditions to really stress-test the system. If this vehicle was going to fail, we wanted to see exactly where and how it would break down. Day 1 arrived, and we fired up the vehicle for the very first time. That's when we encountered our first discovery, and honestly, it caught us completely off guard. See, when you start a regular car with a combustion engine, you get that familiar rumble. That vibration through the steering wheel and seat that tells you the engine is alive and working. Even with conventional electric vehicles, there's usually some kind of sound. A slight whir from the electric motor, maybe a hum from the power inverter. You know the car is doing something even if it's quieter than its gas-guzzling cousins. But this was different. This was silence on a whole other level. I'm not exaggerating when I say it was eerie. We're talking about the kind of absolute quiet that makes you second-guess whether the vehicle is actually running. It felt less like we were operating a machine and more like we were floating in some kind of technological void. No vibration, no mechanical sounds whatsoever. Just pure, unbroken silence. One of our team members actually checked under the hood twice because they were convinced something was not working properly. But no, the vehicle was running perfectly. It was just doing so in a way that defied our expectations of what a running vehicle should sound and feel like. Now, you might be thinking, okay, so it's quiet. Big deal. Lots of electric cars are quiet. But this was our first hint that something fundamentally different was happening under the hood. This wasn't just good sound insulation or efficient motor design. This was something else entirely. Something we couldn't quite put our finger on yet. Then came our second discovery. And this is where things started getting really strange. We'd been driving for about an hour, putting the vehicle through various paces around the city. Traffic lights, accelerations, decelerations, the whole routine. In any normal electric vehicle, you'd watch the battery percentage gradually tick downward. Maybe you'd started at 100%, and now you're at 92%. That's just how it works. Energy gets consumed, battery level drops, simple cause and effect. Except that's not what happened here. We were monitoring the dashboard constantly, eyes glued to that power gauge, waiting to see the inevitable decline. But the battery indicator remained frozen at 100%. Not 99%. Not even 99.9%. Exactly 100%, as if we hadn't moved an inch. We thought maybe the gauge was broken or poorly calibrated, so we drove harder. We accelerated aggressively. We cranked the air conditioning to maximum. We did everything we could think of to draw power from the system. And still, that needle refused to budge. 2 hours in, still at 100%. 3 hours, same story. By the end of that first day, we'd put serious miles on this vehicle, and the battery indicator looked exactly the same as when we'd started that morning. Now, at this point, we were equal parts fascinated and suspicious. Either we were witnessing something truly revolutionary, or there was some kind of trick we hadn't figured out yet. Maybe the gauge was just completely non-functional and meaningless. But the vehicle kept performing flawlessly, so clearly it had power from somewhere. This brings us to discovery number 3, which built directly on what we'd just observed. Anyone who's owned an electric vehicle knows about range anxiety. It's that nagging worry in the back of your mind every time you go on a longer trip. Do I have enough charge to make it there? Where's the nearest charging station? How long will I need to stop and recharge? It's the electric vehicle owner's constant companion. Always calculating, always planning, always aware of that finite energy reserve. But with this vehicle, something remarkable happened. That anxiety just evaporated. Because as we kept driving day after day, the range indicator simply refused to decrease. In a normal EV, you might start with a range of 300 miles, and as you drive, that number counts down. 280, 250, 200, and so on, until you're searching desperately for a charging point. It's a finite resource that depletes with use, just like a gas tank in a traditional car. Not here, though. The range stayed constant. We drove through the entire first day, logged the miles, did the math, and the range indicator hadn't moved. The second day, we specifically planned a route that would normally drain any electric vehicle significantly. Long highway stretches at high speed, then mountain roads with constant elevation changes. Both scenarios are notorious for eating through EV batteries. We're talking conditions that would typically cut your effective range by 30 or 40%. And yet, at the end of that grueling second day, the range indicator still read exactly the same as it had that first morning. It was as if distance had become completely irrelevant. The concept of how far can I go on this charge simply didn't apply anymore. The vehicle seemed to have unlimited range, which should be impossible. Energy doesn't work that way. You can't get something from nothing. Every physics textbook will tell you that. But here we were, witnessing exactly that, or at least something that looked exactly like that. On the third day, we decided it was time to look under the hood. We needed to see what kind of sorcery was actually powering this thing. And that's when we stumbled onto our fourth discovery, which might have been the most unsettling of all. When you pop the hood of a conventional car, you generally know what you're looking at. There's the engine block, the alternator, the battery, all arranged in configurations that have become standard over decades of automotive engineering. Electric vehicles are a bit different, but still familiar. You've got your electric motor, your battery pack, your power electronics, all identifiable and understandable. But when we opened this hood, we found ourselves staring at something that looked almost alien. The components were arranged in ways that made no immediate sense. We couldn't identify a standard battery pack. The motor, if that's even what to call it, didn't resemble any electric motor we'd seen before. There were parts and connections that seemed to defy conventional automotive architecture. It was like looking at a puzzle where someone had mixed in pieces from a completely different set. We brought in someone with extensive automotive engineering background, thinking maybe we were just missing something obvious. But even they stood there scratching their head, unable to definitively explain what they were seeing. The power source wasn't clearly visible or identifiable. The energy conversion system didn't match known designs. It was a completely novel configuration, engineered in a way that suggested an entirely different approach to vehicle propulsion. This wasn't just a better battery or a more efficient motor. This was a fundamentally different paradigm. And that realization sent chills down our spines, because if this was real, if this actually worked the way it seemed to work, then we were looking at something that could rewrite the rules of transportation. Day 4 brought us to our 5th discovery. We'd been relatively gentle with the vehicle up to this point, despite our intensive testing schedule. But now it was time to really push it. We headed for the steepest hills and most challenging terrain we could find. The kind of conditions that make conventional electric vehicles struggle and gasp for power. Steep inclines are the ultimate stress test for EVs because they demand maximum torque and sustained power output, which drains batteries at an accelerated rate. We found a mountain pass with a sustained grade that would challenge any vehicle, started our ascent, fully expecting to see some kind of performance degradation, some sign that the vehicle was working harder, drawing more power, feeling the strain of fighting gravity. In a normal EV, you'd notice the battery percentage dropping faster during climbs. The acceleration might feel slightly less responsive. The vehicle would show signs of effort. But this vehicle climbed that mountain like it was cruising down a flat highway. The acceleration remained crisp and immediate. The power delivery was smooth and unwavering. There was no laboring, no sense that the vehicle was struggling even slightly. And when we checked the battery indicator at the top of that climb, after putting the vehicle through one of the most power-intensive scenarios possible, it hadn't budged, still reading exactly the same as it had at the bottom of the mountain. We descended, then climbed again, and again. We threw everything we could at this vehicle, every challenging road condition we could find. Rocky terrain that made the suspension work overtime, loose gravel that required constant power adjustments. Nothing fazed it. The performance remained absolutely consistent, as if the vehicle had access to bottomless reserves of energy, as if the concept of working hard and draining the battery faster simply didn't apply. Our 6th discovery came when we decided to combine multiple power drains simultaneously. We wanted to see if we could find the breaking point, so we loaded up the vehicle with extra weight. We cranked the air conditioning to maximum and set the heat to full blast simultaneously, just to make the climate control system work as hard as possible. We connected multiple devices to charge, phones, laptops, tablets, anything we could plug in. We turned the sound system up to near maximum volume. We activated every electrical system the vehicle had, every light, every feature, everything drawing power at once. Then we took this fully loaded, maximum drain scenario out on the roughest roads we could find, with lots of acceleration and deceleration. In a conventional electric vehicle, this would be a disaster. You'd watch the battery percentage plummet. The estimated range would drop like a stone. You might even get warnings about power consumption. This is exactly the kind of scenario that causes range anxiety and forces EV owners to carefully manage their power usage. But once again, this vehicle simply absorbed everything we threw at it. The performance didn't degrade. The battery indicator didn't move. The range estimate remained static. It was as if all those power draws, all that energy consumption were just being absorbed by some invisible, unlimited power source. The vehicle didn't care. It just kept going, kept performing, kept defying our expectations and our understanding of how energy systems work. At this point, we were running out of rational explanations. We'd considered the possibility of some hidden reserve battery. Maybe there was some massive energy storage system we weren't seeing, and the gauge was just poorly designed to show the actual depletion. But even if that were true, the sheer amount of energy we'd consumed over these days should have shown some measurable impact. The laws of thermodynamics are pretty clear on this. Energy cannot be created from nothing. It has to come from somewhere. And yet, we couldn't identify where this vehicle's seemingly endless energy supply was actually coming from. Our seventh and final discovery happened almost by accident. On the evening of day 5, we'd parked the vehicle outside overnight. Now, this wasn't just any pleasant evening. We're talking about a cold night, temperatures well below freezing. Anyone who owns an electric vehicle knows that cold weather is the enemy of battery performance. Lithium-ion batteries lose capacity in cold temperatures. An EV that might give you 300 miles of range in summer might only manage 200 in winter. And if you leave an EV sitting in the cold overnight, you'll often see the battery percentage drop even without driving, just from the cold sapping energy from the cells. So we noted the battery level before we left the vehicle that cold evening. Still at maximum, as it had been the entire test, but we were curious if the cold would finally show us some measurable energy loss. The next morning, we came back to a vehicle covered in frost. The windows were iced over. Everything was frozen solid. This was exactly the scenario that would typically show significant battery drain. We fired up the vehicle, checked the battery indicator, and once again found ourselves staring in disbelief. No change, not even a fraction of a percentage point. The cold, which should have sapped energy from any battery system, had no measurable effect whatsoever. It was as if the passage of time, the environmental conditions, the basic physical principles that affect every other electric vehicle simply didn't apply here. The vehicle sat there, frozen and dormant, and emerged the next morning with exactly the same energy level it had before. Now, let me pause here for a moment, because I know what's going through your mind. This sounds impossible. This sounds like it violates fundamental laws of physics. This sounds like either a massive hoax or a complete misunderstanding of what's actually happening. And believe me, we've asked ourselves all those same questions. We've questioned our testing methods, our instruments, our observations. We've looked for hidden tricks or explanations we might have missed. But here's the reality. We tested this vehicle rigorously. We documented everything. And by every observable measure we had available, this vehicle performed exactly as claimed. It generated or accessed power in a way that we couldn't explain through conventional understanding. And that raises some absolutely massive questions. If this technology is real, if it actually works the way it appears to work, what does that mean for our world? Think about the implications for just a moment. The global energy industry is built on the premise that energy is a limited, consumable resource. We extract oil from the ground, refine it into gasoline, and burn it in engines. Or we generate electricity from coal, natural gas, nuclear, or renewable sources, and use that to charge batteries. The entire economic structure of energy is based on scarcity and consumption. A vehicle that generates its own power indefinitely doesn't just disrupt the automotive industry. It threatens the foundations of the global energy economy. What happens to oil companies when cars no longer need gasoline? What happens to the electric grid when vehicles don't need charging? What happens to gas stations, to oil refineries, to the entire infrastructure built around fuel distribution? We're talking about trillions of dollars in existing industry and infrastructure that could potentially become obsolete. And it's not just about economics. Think about the environmental implications. Transportation is one of the largest contributors to carbon emissions globally. If we could eliminate the need for fossil fuel-based transportation, the impact on climate change could be transformative. We could dramatically reduce air pollution in cities. We could cut our dependence on oil extraction with all its environmental costs. The potential benefits for the planet are staggering. But here's where things get complicated, and this is important to understand. Technologies that threaten established industries don't typically get welcomed with open arms. There's a reason you might not have heard about this invention before, even though it could potentially be one of the most important technological developments in decades. When you threaten trillion-dollar industries, when you challenge the economic foundations that powerful entities are built upon, you become a target. History is full of examples of suppressed or delayed technologies. Innovations that threatened existing profit structures often face mysterious obstacles. Funding disappears. Patents get tied up in legal challenges. Inventors face ridicule from establishment figures. Sometimes, promising technologies just seem to vanish from public awareness, buried under skepticism and institutional resistance. It's not always a conspiracy. Sometimes it's just the natural resistance of massive economic systems protecting themselves from disruption. So, why hasn't anyone successfully developed this kind of technology before? Well, maybe they have. Maybe there have been attempts we never heard about. Maybe inventors who got close to breakthroughs found themselves unable to get funding, unable to get patents approved, unable to break through the walls of institutional skepticism. Or maybe this particular inventor has figured out something that others haven't, has approached the problem from an angle that finally made it work. The question of who controls the future of this technology is crucial. Will it be allowed to develop and spread freely? Or will it face the same fate as other potentially disruptive innovations that threatened powerful interests? Who decides whether this reaches markets worldwide or gets quietly shelved? These aren't just theoretical questions. They're urgent concerns about how breakthrough technologies navigate a world where existing power structures have strong incentives to maintain the status quo. Now, I want to address the skeptics directly, because I know many of you are probably thinking this all sounds too good to be true, and you're right to be skeptical. Healthy skepticism is essential when evaluating extraordinary claims. The history of science is full of people who claim to have developed perpetual motion machines or free energy devices, and virtually all of them turned out to be either mistakes or frauds. The laws of thermodynamics have held up remarkably well over centuries of testing. But here's the thing about dismissing something as impossible. Every major breakthrough in human history was considered impossible right up until it wasn't. Heavier-than-air flight was impossible until the Wright brothers did it. Splitting the atom was theoretical fantasy until it became devastating reality. Landing humans on the moon was science fiction until it was televised fact. The smartphone you're probably watching this on would have seemed like magic to someone just a few decades ago. The difference between fantasy and breakthrough is evidence. And while I can't explain the physics of how this vehicle works, while I can't give you a complete theoretical framework that makes sense of what we observed, I can tell you what we saw with our own eyes. We saw a vehicle that performed in ways that conventional technology can't explain. We documented it, tested it, pushed it to its limits, and it consistently behaved in ways that defied our expectations. Does that mean it's definitely what it claims to be? No, not necessarily. There could be explanations we're missing. There could be hidden components or systems we didn't detect. Our testing, while rigorous, wasn't conducted in a controlled laboratory setting with sophisticated measurement equipment. We're not claiming to have definitively proven anything beyond reasonable doubt. What we're saying is that we witnessed something highly unusual that deserves further investigation and open-minded inquiry. The automotive industry is notoriously conservative, and for good reason. When you're building vehicles that people trust with their lives, you don't take chances on unproven technologies. Safety standards are rigorous. Engineering practices are well established. There's a reason cars have evolved incrementally over decades rather than through revolutionary leaps. But that conservative approach, while ensuring safety and reliability, can also create resistance to genuine innovation. When someone comes along proposing something that fundamentally challenges established engineering principles, they face enormous obstacles. They're entering an exclusive club uninvited, challenging experts who've spent careers mastering conventional approaches. The default response is often dismissal, and sometimes that dismissal is warranted because the claims don't hold up to scrutiny. But sometimes, just sometimes, the outsider with the crazy idea is actually onto something real. What we witnessed during our week with this vehicle falls into that category of observations that demand further investigation. It's not proof of anything definitive, but it's evidence of something unusual, something that doesn't fit neatly into our current understanding. And that's exactly the kind of thing that should spark curiosity rather than automatic dismissal. The silence of the vehicle, that eerie absence of mechanical sound, suggested an energy conversion process unlike conventional motors. The static battery indicator implied either a measurement system completely divorced from reality or an energy source that replenished itself as fast as it was consumed. The unchanging range estimate pointed to something that defied the finite limitations we associate with stored energy. The mysterious components under the hood indicated engineering approaches that diverged from established automotive design. The consistent performance under stress suggested access to power reserves that didn't deplete under load. The resistance to environmental conditions like cold indicated battery chemistry or energy storage that didn't follow normal rules. Each of these observations individually could potentially have conventional explanations. Maybe the silence is just exceptional engineering and soundproofing. Maybe the battery indicator is simply broken or poorly designed. Maybe the range estimate is based on some optimistic algorithm. Maybe the components under the hood are just arranged unusually without being fundamentally different. Maybe performance consistency is achievable through really good power management systems. Maybe the cold resistance is just excellent thermal insulation. But when you put all these observations together, when you see this complete package of unusual characteristics all in one vehicle, the conventional explanations start to feel inadequate. It's like seeing smoke, feeling heat, seeing flames, and smelling burning, but being told there's no fire. At some point, the collection of evidence points toward something significant even if you can't fully explain it yet. This is a story about pushing boundaries, about questioning assumptions, about being willing to investigate ideas that sound impossible, because sometimes the impossible is just the not yet achieved. It's about recognizing that our current understanding, while extensive, isn't complete. There are still mysteries in physics, still unknowns in energy science, still possibilities we haven't fully explored. The journey of discovery is rarely straightforward. It's filled with dead ends, false starts, challenges to conventional wisdom that turn out to be wrong, and occasional genuine breakthroughs that change everything. We don't know yet which category this invention ultimately falls into, but we know it deserves serious attention, rigorous testing by qualified experts, and open-minded investigation rather than reflexive dismissal. So, where does this leave us? What's the takeaway from this wild week of testing and these 7 mind-bending discoveries? I think the main message is this: stay curious. Stay open to possibilities, even when they challenge what you think you know. Question both wild claims and conventional wisdom. Demand evidence, but be willing to follow that evidence wherever it leads, even if it's somewhere unexpected. The future of transportation might look very different from what we imagine. Maybe self-powered vehicles will become reality. Maybe this particular invention is the breakthrough that makes it happen. Or maybe it's a stepping stone toward something even better. Maybe conventional wisdom is right, and there's a mundane explanation for everything we observed. We don't have all the answers yet, and that's okay. That's actually exciting because it means there's still discovery ahead. What we do know is this: innovation happens when people dare to question the impossible. Progress comes from those willing to challenge established norms. Breakthroughs emerge when inventors pursue ideas that everyone else dismissed. And sometimes, just sometimes, the crazy idea that sounds too good to be true turns out to be the beginning of something world-changing. So keep your mind open, keep questioning, keep exploring, because the next big breakthrough might be happening right now, in some workshop or garage, developed by someone who refused to accept that something was impossible. And when that breakthrough comes, the world changes in ways we can barely imagine. If this journey fascinated you as much as it fascinated us, if you love exploring the cutting edge of what's possible, if you believe in the power of innovation to reshape our future, then I want you to do something. Hit that like button, because it tells us you want more content like this. Subscribe and turn on notifications. because we're committed to bringing you the most extraordinary innovations and discoveries that are shaping our world. Drop a comment below and tell us what you think. Do you believe this technology is real? Are you skeptical? What questions do you have? We read every comment, and your thoughts shape the content we create. We're all on this journey of discovery together, exploring the mysteries that drive our world forward, questioning what's possible, and witnessing the innovations that might just change everything. Thank you for coming along on this wild ride. Until next time, keep exploring, keep questioning, and never stop wondering what's possible.